Hey guys, Mr. Backer here. In this video we're going to look at quadratic functions and their graphs. When we're talking about a quadratic function, we're talking about a function that has a degree of 2. So what that means is we're going to be seeing an x squared in our function. Now if we think about just the parent function f of x equals x squared, that graph is going to give us a parabola, and its vertex is going to be centered right at the origin. Now every single graph for an x squared function will be a parabola. If our x squared is positive in our function, then it'll be an upwards opening parabola. But if we were looking at something like f of x equals negative x squared, then that negative out in front is an x-axis reflection, meaning that our parabola would open downward instead. So in this example, we want to take a look at our normal f of x equals x squared function, but we're going to perform some transformations, and we want to figure out what those different transformations would do to the graph of our original parabola. So we're looking at the function g of x equals negative 1/2 x squared plus 3. And we're going to look at what each one of those changes does. So the first thing I'm looking at is that 1/2 in front of my x squared. And when we multiply our x squared by that 1/2, that's going to be a vertical shrink by a factor of 1/2. Now the next thing I'm looking at is that negative that's out in front of the 1/2. And that negative is going to reflect our parabola over the x-axis, meaning that our parabola is going to open downwards instead of upwards. And then the last thing we've got in here is that plus 3. And since that plus 3 is not happening directly to our x, it's happening outside of the function, that plus 3 is going to move our graph up 3 spaces. Same idea, but let's look at a new function now. So now we have h of x equals 3 times x plus 2 squared minus 1. And we're going to look at what all of these changes do to the graph of our parabola. So the first thing I'm looking at this time is the plus 2 that's happening inside of our parentheses. Since that plus 2 is happening on the inside, it's going to be a horizontal shift, and horizontal shifts are always backwards of the way we would think they would be. So plus 2 actually shifts us left 2 spaces. Then I'm looking at that times 3 in front of my parentheses, and that times 3 is going to be a vertical stretch by a factor of 3. And then the last thing I'm looking at is that minus 1 on the back end of my function. Because we're subtracting, that's going to shift our graph down 1 space. Now as we're looking at a quadratic function or a quadratic equation, we are used to looking at quadratic equations in the form y equals ax squared plus bx plus c. And that's helpful if we're trying to solve a quadratic and say we're trying to run the quadratic formula. Then it's important for us to be able to identify our a, our b, and our c values. But we're actually going to look at a different form, a different way of writing out a quadratic function, and that's going to be something called vertex form. So what we're going to look at is we're going to look at some function f of x, and what we're going to have is a times x minus h squared plus k. And this vertex form is going to tell us some important information, mainly where the vertex of our parabola is. And the vertex of the parabola is either the highest or lowest point, depending on if our parabola is opening up or down. And in order to find the vertex from vertex form, we want to look at our h and our k values. So the vertex is the point h comma k. And there's also an important line that splits our parabola in half. It's called the axis of symmetry. And the axis of symmetry is the vertical line going through x equals h. So in this example, we're going to look at taking a quadratic function that's written out in standard form, and we're going to rewrite it in vertex form so that we can identify the vertex of our parabola and also the axis of symmetry. In order to take a quadratic function that's in standard form and rewrite it in vertex form, we're going to need to remember how to complete the square. And when we're looking at completing the square, the first thing that we need to check is that our a value in front of the x squared is a 1. In this case, it is, so we don't have to do any pre-work before we start completing the square. So when we complete the square, we want to look at the b value, and we're going to take b and divide it by 2, and then we're going to square it. Okay, so what I'm going to do in this function is I can see that I've got a b value of -6. So I'm going to take -6 divided by 2, which ends up being -3, but then I'm going to square that, and when I do that, I'm going to get 9. So in my quadratic function, what I'm going to do is I'm going to leave the x squared alone, I'm going to leave the -6x alone, and I'm going to leave the 12 alone, but I'm going to put a little bit of space in here because I need to account for that 9. Now when we're completing the square, what we're going to do is we're going to add that 9 in there because that's going to create a nice factorable quadratic right here. But we can't just add 9 to one side of the equation without throwing the balance off. So we're actually going to do something called adding 0. So when we add the 9 in here, I also need to subtract the 9 to make sure I'm not throwing the balance of my equation off at all. So with a +9 and a -9 in there, we've essentially added 0 to this function, so we haven't changed the balance at all. Now what we're going to look at doing is we're going to factor out that stuff inside of the parentheses. So we should be thinking sum and product factoring. So we want to think about things that multiply to 9 but add up to -6. So that would be x minus 3 and x minus 3. And because that's a repeated factor, we can shorten that into being x minus 3 squared. Now on the back end, we've got this -9 and this +12 that we can combine together. So we're going to get +3. So now by completing this square, we've taken our quadratic function that was written out in standard form, and it's now written in vertex form. So if I want to identify the vertex of my parabola, then I need to look at my h and my k values. So h is the number inside of parentheses, and what we want to do with that is we want to do a sign change on it. So I know it says a -3 in there, but when we're looking at the h value, we sign change that to actually be a +3. The h value is the number that's being subtracted from the x, and 3 is what's being subtracted. But then the k value on the end, we want to use that value just as is. So the vertex of my parabola is at 3, 3. And then as far as the axis of symmetry, that is the vertical line, so it's an x equals line, and it's going to run through the x value from the vertex. So it goes through the h value there. So that would be x equals 3 as the axis of symmetry. Now we're looking at doing another problem where we're given a quadratic function in standard form, and we want to rewrite it in vertex form so that we can identify the vertex of our parabola and the axis of symmetry. But the big difference about this one is we now have an a value in front of our x squared that is something other than 1. So we need to do a little bit of work before we can start completing the square. So what I'm going to focus on is I'm actually just going to look at these first two terms in here, the 3x squared and the 12x. And what I need to do is I need to factor the 3 out of here so that I end up with an a value of just 1. So then I would get 3 times x squared plus 4x, and then plus 11 on the back end. We're not going to try to factor the 3 out of the 11, because 3 just isn't going to factor nicely out of 11. But now what we're going to look at doing is we're going to focus inside of our parentheses right now, and we're going to do our completing the square. So we've got ourselves a b value of 4, so I'm going to do b over 2, so 4 over 2 squared, and when we do that, we end up getting 4. Now what I want to do is I'm going to leave the 3 alone, I'm going to leave the x squared alone, and I'm going to leave the plus 4x alone, but then I'm going to leave a little bit of space inside of my parentheses with my plus 11 on the end, because now we need to do our whole adding 0 with this 4 in here. So I'm going to add the 4 inside of the parentheses, but then I also need to subtract the 4 inside of the parentheses. So when we add the 4, we have to subtract the 4 to make sure that we're not throwing the balance of our equation off. Now when we do that, that creates our nice factorable set in the front here. So if we think sum and product factoring, we need things to multiply to 4 but also add up to 4. So we're looking at x plus 2 and x plus 2. And because that's a nice repeated factor, we can shorten that into being x plus 2 squared. Now, inside of this larger red set of parentheses, we still have that extra minus 4 with that 3 hanging out on the outside and the plus 11 on the back end. Now, we do need to do a little bit of cleaning up in here. And what I'm looking at doing is taking that 3 that's out in front of my big set of parentheses, and we're going to distribute the 3 in. Now, because of the squared power on this green information, I can't actually take the 3 and multiply it inside of the parentheses. So what I have to do is just drop the 3 in front of the x plus 2 squared. But now I need to take the 3 and multiply it to the negative 4 to get negative 12. And now that I've done that multiplication, then this larger set of parentheses is no longer necessary. So I still have that plus 11 on the back end. And I'm going to need to do some combining like terms with the negative 12 and the plus 11. So my final vertex form of my quadratic is going to be 3 times x plus 2 squared minus 1. So then I should be able to identify my vertex looking at my h and my k values. And my vertex is going to be at negative 2, negative 1. And then I should also be able to identify my axis of symmetry. And the axis of symmetry is x equals the h value, so x equals negative 2. Now there is actually a shortcut that we can use instead of going through and doing the whole completing the square process. So we're going to take a look at this function, g of x equals negative 3x squared plus 6x minus 5. And similar to when we're doing the quadratic formula, I'm going to look at what my a, b, and c values are. So my a is the number in front of the x squared, so that's a negative 3. My b is the number on the plane x, so that's 6. And my c is the constant term on the back end with no variable attached to it, so that's a negative 5. In order to get our h value, what we can actually do is take the opposite of b over 2a. So as we're looking at the information that we've got, our b value is 6. So if we do the opposite of 6, and that's going to be negative 6, over 2 times negative 3. Now on bottom, 2 times negative 3 is negative 6, and negative 6 divided by negative 6 gives us an h value of 1. And now what we can do with that is, in order to find our k value, we want to look at f of h. So in this case, we're going to look at f of 1. And what that means is in our function, where the x is, we're going to replace the x with a 1. So we're going to get negative 3 times 1 squared plus 6 times 1 minus 5. And when we do all that, that should simplify down to negative 2. So we actually have all of the information that we need in order to be able to write out our vertex form for our quadratic. To be in vertex form, we want to take a times x minus h squared plus k. So we actually know our a value. It's the same exact a value that we identified earlier. So we're going to take the negative 3 times x minus our h value, so minus 1, squared, plus that k value of negative 2. Now I can actually do a little bit of rewriting on this. With the plus a negative 2 on the back end, I can just write that as minus 2. So now if I look at my vertex is going to be at the point 1, negative 2. And my axis of symmetry is going to be the line x equals 1. That's going to be it for this video. Thanks for watching.